Hello there, and welcome to Science for Sleep, where curiosity gets cozy and science tiptoes gently into the land of dreams. Tonight, we'll be sinking slowly into something astonishingly small. So small, in fact, that you could hold one in your hand and still not know you were holding anything at all. Atoms, the tiniest building blocks of everything we know, everything we love, fear, taste, touch, breathe, and believe to be real. Your pillow, the sound of my voice, the moon outside your window, all of it. Arranged delicately out of things we can never quite see. And yet, what are they really? Are atoms little specks of matter, like microscopic marbles? Are they more like clouds? Or are they not things at all, but rather tiny dances of energy, flickering in and out of existence when we dare to look? It's strange to think that reality itself, the entire theatre in which our lives unfold, might be made of something that's mostly empty space. Stranger still to realise we're made of that same emptiness. So let me ask, where are you listening from tonight? And if you glanced at a clock, what time is it right now, there in your quiet corner of the world? Because wherever you are and whenever this finds you, you're sitting on a world made of trillions upon trillions of atoms, and not a single one of them knows you're listening to a story about them. If you find this curious, or calming, or if you simply need a gentle companion to drift off beside, I'd be ever so grateful if you tapped the like button, maybe subscribed, or passed this little piece of peace along to someone else in need of stillness. Now, settle in. Let your thoughts float like particles in slow motion, and let's begin. Because somewhere between electrons and dreams, between the heartbeat of a hydrogen atom and the hush of a sleeping planet, lies the story of what we're made of. You've never seen an atom, not directly anyway, not in the way you see the leaves outside your window or the warm glow of a lamp across the room, and yet every part of you, your thoughts, your breath, your heartbeat and your memories, is made of them. Isn't that curious? To live a whole life inside a world built from invisible things, and never once be sure what those things truly are. You run your fingers across a wooden table. It feels solid, dependable, and yet science tells us that it's mostly emptiness, vast spaces between tiny whirling particles. So why doesn't it feel empty? Why don't you fall through the floor? Why does your hand stop when it meets the wall if the wall is made of almost nothing? It's as if we're walking through a dream with bones and gravity. Something that feels real not because it is solid, but because we experience it as solid. Our senses tell us so. Our brain agrees. And so we trust. Reality, then, is not just what is there. It's also what we perceive. Have you ever closed your eyes and tried to imagine what it would feel like to not have a body? To float in space with no weight, no skin, no shape, just awareness. It's unsettling, isn't it? We define ourselves by what we can touch. The texture of bed sheets, the coolness of a glass, the pressure of your back against a chair, and all of it is made of atoms. But the funny thing is, atoms don't have texture in the way we think. They don't have colour, or smell, or taste. They don't even really touch. When your fingertip presses against something, a mug, a cat, the hand of someone you love, it's not the atoms merging. It's their electric fields repelling, a microscopic dance of resistance. You never actually make contact, and yet you feel it. You swear by it. Reality, then, is not contact. It's interaction, perception. It's the feeling of being here. We move through our days as though the world were concrete. We trust the walls not to vanish, the air not to dissolve, the floor not to give way beneath our feet. But that trust is built on something far stranger than stone or steel. It's built on illusions that work so well, we forget they're illusions at all. Take colour. You look at a ripe strawberry and call it red, but atoms aren't red, or green, or any colour really. The fruit reflects certain wavelengths of light, and your brain translates those vibrations into redness. It's a brilliant trick of the nervous system, a symphony of light and interpretation. Without consciousness, colour doesn't exist. And still, you can picture red in your mind, can't you? Even with your eyes closed. So what's more real? The atoms themselves, or the way they feel to us? Smell is the same, the scent of rain, or cinnamon, or the warmth of someone's skin after they've been in the sun. All of those begin as molecules floating through the air. They enter your nose, tickle a receptor, send a signal to your brain. But that's not the smell. The smell is what happens inside your mind when electricity becomes memory, emotion, nostalgia. Atoms trigger the experience, but they aren't the experience. In a way, you never truly know the world. You only know your translation of it. A continuous symphonic hallucination constructed out of data and meaning. That may sound disorienting, even a little spooky, but it's also kind of magical, isn't it? Because it means that reality isn't something cold and fixed. It's something living, interpreted. It changes with us, through us. Think of music. When you listen to a piano note, you're not hearing atoms, you're hearing vibrations, waves moving through air. A compression of molecules that your ears catch and your brain turns into sound. Atoms don't hum. They don't care if a song is sad or joyful, but you do. So again, what's more real? The motion of particles in the air, or the ache in your chest when you hear a familiar melody? There's a theory in cognitive science that perception is less about detecting the world and more about predicting it. Your brain is constantly guessing. What should this feel like? What colour will that be? What happens next? And most of the time it gets it right. But once in a while it doesn't. You mishear something, misremember. You see a shadow that wasn't there, and for a second reality shifts. Not because the atoms changed, but because your mind did. It's like that with dreams too. You can wake from a dream sweating, heart pounding, mind reeling, as if you had lived something real, and yet nothing was there. No atoms arranged themselves into dragons or forgotten lovers or infinite staircases, and still you felt it. It shaped you. So which matters more, the atoms that weren't there or the emotional residue left behind? We tend to think of matter as the real stuff, the scaffolding of existence. But what if the scaffolding is only half the picture? What if consciousness is the other half? After all, a world made entirely of atoms, with no eyes to see it, no hands to touch it, no minds to wonder, would still be there, yes, but would it matter? Maybe reality, as we live it, exists only at the meeting point of particle and perception. There's a beautiful word for that moment when something internal meets something external and becomes meaningful. It's called qualia, the subjective quality of experience, the way lavender smells to you, the taste of cold water when you're truly thirsty, the colour blue, not in theory, but in your mind. Atoms don't have qualia, but you do, and that makes all the difference. This isn't to say that physical reality isn't real, only that it may be incomplete, without us to feel it, without a mind to say, this is soft, that is warm, this makes me cry. It's possible, maybe even likely, that the universe has always been full of atoms, but it was only when life emerged, and later consciousness, that those atoms became something more. A tree, a song, a friend. Somewhere along the chain of complexity, atoms stopped being building blocks, and started being meaning. Or maybe they were always both. You're made of atoms, yes, but also stories, memories, moments, and no microscope can see those. It's tempting to think that science should explain everything, that if we just zoom in far enough, break it down into small enough pieces, we'll finally find the real reality hiding underneath. But what if it's not like that? What if the closer we look, the fuzzier things get? That's what happens when we get down to the atomic level. Solidity disappears, certainty dissolves. We move from particles to probabilities, from classical physics to quantum confusion. And yet, despite all that, we still fall in love, still miss people, still lie awake wondering what it all means. We are beings of thought and matter, orbiting slowly in a universe that we can only partially understand. But maybe that's enough, to wonder, to reach out, to ask, what is all this made of? And what am I made of it? There's something comforting in not knowing everything, in admitting that the world is bigger and smaller and stranger than we can see. Because it means we can always keep dreaming, keep asking, keep listening. The atoms may not care, but we do, and that perhaps is what makes it real. Long before microscopes, long before laboratories, long before electrons had names or nuclei were charted, we still wondered, what is the world made of? Not just the obvious things, wood, stone, water, flesh, but the deeper stuff, the essence, the hidden bones of the universe, the invisible thread that ties the stars to the soil, the wind to the whisper of breath. You can almost imagine someone sitting by a fire thousands of years ago, staring into the flames and thinking, what is this? And why does it burn? That question, what everything is made of, has echoed through time like a heartbeat, soft but persistent. And while modern science eventually arrived at atoms and particles and quarks, human beings have always had a way of answering it, even without the math. Let's begin at the beginning. The ancient Greeks, so fond of questions, were among the first to leave us written clues. Around the 5th century BCE, a philosopher named Democritus proposed a radical idea, that all things, no matter how complex, are made from tiny indivisible bits. He called them atomos, meaning uncuttable. He imagined a world in which everything, earth, air, fire, even the soul, was built from these invisible units, differing in shape and motion, swirling endlessly through the void. According to Democritus, nothing truly vanished. It simply changed form, as atoms rearranged themselves. His ideas weren't widely embraced at the time. You see, the popular view then, especially among followers of Aristotle, was that all matter was made from 4 classical elements: earth, air, fire, and water. Not particles, but principles, each one tied not just to physical matter, but to qualities. Earth was heavy and still, air was light and shifting, fire transformed, water flowed, and everything in existence, from mountains to moods, was thought to be a blend of these forces. Fire in the mind, water in the blood, earth in the bones. It wasn't chemistry, not yet, but it was a kind of poetic science, an attempt to bring order to a chaotic world, and for a long time it worked. The ancient Chinese developed a similar system with 5 elements: wood, fire, earth, metal, and water, each flowing into the next in a cycle of balance. These elements weren't just substances, they were energies, directions, emotions, the rhythm of the universe expressed in metaphor. Meanwhile, in India, Vedic thinkers spoke of Pancha Mahabhuta, the 5 great elements: earth, water, fire, air, and akasha, or space. Together they formed the body, the cosmos, and the sacred breath between them. Even the mind, they said, was shaped by the elements. Matter and spirit were never fully separate. It wasn't science exactly, not by today's standards. But it was something else, a framework for meaning, a way of seeing the world as coherent, interconnected, and alive. And perhaps that's the most important thing to remember, that these ancient systems weren't just trying to describe what the world is made of, but why it matters. To know the elements was to know yourself. To balance them was to be well. Later, alchemists would pick up that thread, weaving mysticism with early chemistry. In Egypt, Persia, China, and later medieval Europe, alchemists believed that all matter could be transformed. That lead could become gold, that base metals held within them a spark of perfection, waiting to be awakened. They didn't talk about atoms, not yet, but they were obsessed with change, with transmutation, with essence. They believed that everything visible was a reflection of something invisible, that behind every stone, every herb, every flicker of a flame, there was a pattern, and if you could learn that pattern, you could unlock the secrets of reality itself. Of course, much of it was metaphor wrapped in riddle, but within the symbols, dragons, crucibles, the philosopher's stone, there was a yearning, a belief that matter wasn't just inert stuff. It was a puzzle, a poem, a code. You could say they were wrong about the details, but you'd be missing the point. They were asking the same question we still ask today. How can the universe be both so solid and so mysterious? Meanwhile, halfway across the world, indigenous cosmologies were answering that question in their own ways. In many Native American traditions, matter was not seen as passive or lifeless. Rocks, rivers, trees, all were imbued with spirit. Not metaphorical spirit, but literal presence, an awareness, a kind of consciousness that moved through all things. To touch the earth was to enter into relationship with it. The Maori of Aotearoa speak of Maori, the life force that exists in every part of creation, from mountains to feathers to carved wood. In their worldview, the world is made not just of materials, but of meaningful being, and the line between people and particles is thin. Likewise, many African cosmologies describe the material world as charged with ancestral energy. In the Yoruba tradition, for instance, elements like iron or water are not just substances, they're manifestations of orishas, spiritual forces with personality and agency. A river is not just a river, it is a being, a story. These ways of seeing weren't based on microscopes or physics, but they weren't primitive. They were relational. They understood that matter is never separate from meaning. And in some strange and beautiful way, modern science is beginning to echo that sentiment. Because now we know that you can't look at a particle without changing it. That observation matters. That the act of measuring the world transforms it. And maybe, just maybe, that's not so different from saying the world is alive. But before we get to that, let's pause in one more place, the world of words. Language, too, shapes how we understand reality. In English, we often treat matter as stuff, material to be used, consumed, shaped. But in many other languages, the line between object and being is more fluid. Some tongues don't even separate nouns and verbs the way we do. The philosopher David Abram notes that in the Ojibwe language, stones and rivers are described with animate verbs. They do, rather than they are. Imagine living in a world where a mountain listens, where wind doesn't just blow, it remembers. In Japanese, the word mono no aware expresses a gentle sadness at the impermanence of things, a kind of emotional awareness that everything, even matter, is transient. It reflects a cultural intuition that reality is both beautiful and brief. And in many mystical traditions, Sufi, Buddhist, Kabbalistic, the material world is seen as a veil, a reflection, a symbol, not false, but incomplete. Something to be peered through, not just at. In all of these ways, across cultures and centuries, human beings have tried to explain matter not as dead stuff, but as living mystery. And even as we've moved into the realm of laboratories and lasers, that sense of awe has never fully left us. Think of how we talk about atoms today. They're particles, waves, fields, vibrations. They exist, and yet they don't. They are here, but not until we look. We'll explore that strangeness in the next section, but for now, it's enough to say this. The question of what reality is made of has never just been about molecules. It's been about meaning, about relationship, about wonder. Democritus gave us the first atomic theory, but long before him, the poets were already whispering, we are made of earth and air, fire and water, space and memory. And something else too, something unnamed, something timeless, something that breathes through every leaf, every stone, every star, and every sleeping heart. And if that's not reality, then maybe it's the part of it we most need to remember. So, what is an atom really? After all the myths, metaphors and ancient whispers, what does science say now that we can look a little closer? Well, first a surprise. An atom, the so-called building block of matter, is mostly nothing. If you were to take a single atom and blow it up to the size of a football stadium, the nucleus, the dense heart of the atom, would be about the size of a marble at the centre of the field. Everything else? Empty space. The electrons would be tiny blurs dancing around the outer edge like bees circling an invisible hive, but with no clear orbit, no solid path, just probability. A shimmering cloud of maybe. And yet somehow this almost nothingness makes up everything. Your skin, your lungs, your favourite blanket, the stars, the tea cooling beside your bed, the voice you're hearing now. All of it constructed from tiny fields of mostly empty space, held together by forces you can't feel directly, but that never stop shaping you. Atoms, in the simplest terms, are made of three basic parts: protons, positively charged; neutrons, neutral; electrons, negatively charged. The protons and neutrons huddle together at the centre, forming the nucleus, a dense, compact core where nearly all of the atom's mass resides. It's heavy, it's tight, it's ancient. The electrons, far lighter and full of motion, swirl around that core, not in neat planetary circles like we once thought, but in strange, probabilistic orbits. They don't move in tracks. They exist in clouds, and this is important because atoms don't behave like marbles or ping-pong balls. They don't sit still or stack neatly. They flicker, they vibrate, they exist as tendencies, not certainties. This was one of the great surprises of the 20th century. Up until then, people imagined atoms like tiny solar systems, electrons orbiting a nucleus the way planets orbit a sun. It was neat, predictable, familiar. But nature, as it turns out, is far stranger than our metaphors. Enter quantum mechanics. In quantum theory, particles like electrons are not solid dots zipping around. Instead, they are better described as waves of probability, mathematical clouds that tell us where they're likely to be found, not where they are. You can't say exactly where an electron is, you can only say where it might be. It's like trying to hold fog in your hands. This fuzziness isn't just a failure to measure, it's built into the nature of reality itself. According to the Heisenberg uncertainty principle, you can't know both the position and momentum of a particle with perfect accuracy. The more precisely you try to pin it down, the less you know about how fast it's moving, and vice versa. Reality at this scale is not a map with clear roads, it's a mist, a shimmering, flickering fog that behaves more like music than machinery. And yet, when you zoom out, trillions of atoms form something solid, reliable, tangible. That's the great paradox of atomic structure, how so much uncertainty creates something that feels so certain. It's worth pausing here to notice the strangeness. The world feels still, but it's not. It's in constant motion. Your body feels solid, but it's mostly space. Everything feels certain, but it's made from particles that don't even know where they are. Let's go a little deeper. Each atom is defined by how many protons it has. That number is called its atomic number, and it determines what kind of element the atom belongs to. Hydrogen has 1 proton, helium has 2, lithium has 3, and so on. Change the number of protons and you've got a completely different element. Change the number of neutrons and you've got an isotope. Same element, different mass. Sometimes stable, sometimes radioactive. Change the number of electrons and you've got an ion. A charged version of the atom, more reactive, more eager to connect. These simple variations, just one more or one fewer particle, can completely transform an atom's behaviour. Add a neutron and you might create fuel for a star. Remove one and you might create medicine. Rearrange correctly, the same basic particles can become salt, or poison, or the taste of sugar on your tongue. That's the magic of atomic structure. It's not just what you have, it's how it's arranged. The periodic table, the grid of elements you might remember from school, isn't just a list of ingredients, it's a map of behaviour, a story of how atoms relate to one another, how they bond, how they build. And it's those bonds, the way atoms link together, that allow for complexity. A single atom is powerful, but atoms rarely travel alone. They connect. They share electrons in shimmering agreements called chemical bonds. Some share nicely, like in covalent bonds. Some give and take, like in ionic bonds. And others dance loosely, like in metallic bonds. Electrons drifting freely like communal light. These atomic handshakes are what let molecules form. And molecules, they're the alphabet of matter. H2O becomes water, CO2 becomes breath, DNA becomes life. Just a handful of atomic symbols rearranged in infinite combinations to create everything from coral reefs to concertos to the curve of your hand resting gently on a page. The elegance is staggering, and yet none of this would be possible without one more force, the electromagnetic force. You felt it before, even if you didn't know it. When a balloon sticks to your hair, when static crackles on a sweater, when your feet shuffle across carpet and reach for a doorknob with a spark. But deep down, this force does far more. It's what keeps electrons bound to nuclei, what prevents atoms from collapsing in on themselves. It's what allows your fingers to feel texture. Because remember, you never actually touch anything. What you feel is the electromagnetic resistance between your atoms and the atoms of what you're reaching for. It's the invisible no that says, here is where you stop, here is where you begin. And that simple pushback, that unseen field, is what gives the illusion of solidity. You never quite meet the world, you approach it, and that's enough. Pause here, let it settle. You're a cloud of probability, held in shape by tiny dancing charges, floating in space that isn't really empty, just humming quietly beneath your awareness, and yet you feel real, grounded, alive. That is the quiet brilliance of atoms. They are both less and more than we imagine. They are structure, but also story. They are matter, but also metaphor. You can see their echoes in crystal lattices, in the spiral of a shell, in the stretch of a muscle, in the double helix of your DNA. Atoms don't know they're building beauty. They simply follow the rules of attraction. And yet, somehow, they do. We'll continue in a moment. We haven't yet touched on the nucleus, or the strong force, or the strange zoo of particles that lie even deeper than atoms. But for now, just rest here, in the knowledge that you are made of things you cannot see, cannot hold, and yet cannot live without. Atoms, tiny mysteries, old as the stars, whispering the shape of everything you are. At the heart of every atom is a tightly packed cluster of protons and neutrons. They don't swirl, they don't orbit, they sit, locked in an embrace so intense that it takes one of the strongest forces in nature to hold them there. We call it the strong nuclear force, and it really is strong. It's the glue of the universe, but with a catch. It only works over incredibly short distances, so short, in fact, that if protons drift even slightly too far from each other, the whole thing begins to fall apart. You might wonder, why do we need a strong force in the first place? Because protons all carry a positive charge, and like charges repel. So inside the nucleus, there's a quiet battle going on between the electromagnetic force trying to push protons apart and the strong force holding them together. Neutrons help too. They don't carry charge, but they act like buffers, space makers that reduce repulsion, keeping things stable. But the balance isn't always perfect. Some nuclei are too heavy, too crowded. They begin to wobble, to split, to emit particles or energy. This is what we call radioactivity. An unstable atom trying to become more stable by letting go of a little mass, a little energy, a little light. And sometimes, when a nucleus splits in just the right way, it releases a burst of energy so powerful it can warm cities or destroy them. That's nuclear fission, the same process that powers some of our submarines, and tragically our bombs. It's a reminder, atoms are small, but not weak. Their hearts contain the kind of energy stars are made of, because they are made of stars. Every atom heavier than hydrogen, carbon, oxygen, iron, gold, was forged in the heart of an ancient star, pressed into being by gravity, heat, and time. And when that star died, exploding outward in a supernova, it scattered its atoms across space. Some of those atoms drifted for eons, through dust and silence, until they found their way here, into oceans, into trees, into you. It's often said we're made of stardust, but that's not poetry, that's atomic history. Now let's go even deeper. You've met the three familiar parts of the atom: electrons, protons, and neutrons. But even those aren't fundamental. Electrons, as far as we know, they're elementary particles. They don't have subparts. But protons and neutrons, they're made of something smaller still: quarks. Quarks are strange little things. They come in 6 flavours: up, down, charm, strange, top, and bottom. Protons are made of 2 up quarks and 1 down. Neutrons are 2 down, 1 up. They're held together by gluons, particles that act as the carriers of the strong force. Yes, gluons, because they glue quarks together. It sounds whimsical, but it's very real. Without gluons, there would be no atoms, no molecules, no chemistry, no hands to hold, no stars to shine. And beyond that, beyond quarks and electrons, that's where things become less clear. You enter the realm of the standard model of particle physics, the current best guess at what reality is made of, on the tiniest possible scales. It includes particles like photons, carriers of light, and the electromagnetic force, W and Z bosons, responsible for radioactive decay, Higgs boson, the so-called God particle that gives mass to others, neutrinos, ghost-like particles that pass through your body by the trillions every second, and of course, the graviton, a hypothetical particle that would explain gravity, though we've never seen it. Together these particles, and the forces they carry, form the scaffolding of everything we know, and yet it's not complete. There are gaps, mysteries, unexplained phenomena, entire parts of the cosmos, like dark matter and dark energy, that seem to operate with their own hidden rules. We can't see them, we can't touch them, but we know they're there, because the galaxies spin too fast, because the universe expands too quickly, because the math doesn't work unless something invisible is holding it all together. It's a humbling truth. We've split atoms, unlocked energy, mapped the periodic table, and still, most of the universe is made of something we don't understand. And perhaps that's fitting, because the closer we look, the more reality seems to shimmer. Particles behave like waves. Waves act like particles. Sometimes things don't exist until we observe them, and sometimes just looking at something changes what it is. It's tempting to ask, what are atoms really? Are they solid bits? Are they probability clouds? Are they vibrations in hidden dimensions? Maybe they're all of those. Maybe they're none. Some physicists propose that atoms, and indeed all of matter, are not made of stuff at all, but of fields. Invisible fundamental fields that fill all of space. Each type of particle is just a ripple in its corresponding field. A photon, a ripple in the electromagnetic field, an electron, a ripple in the electron field, a quark, a tiny bump in the quark field. In this view, you're not made of particles, you're made of ripples, vibrations, geometry, singing, The universe as music, matter as movement. It's not a new idea. The ancient Hindus spoke of the cosmos as sound, the sacred syllable Om, vibrating through all things. String theory, a modern but still speculative framework, suggests that the tiniest constituents of matter are not particles at all, but vibrating strings of energy, each with its own frequency, each note becoming a different particle. The same string that hums as an electron in one octave might hum as a graviton in another. Matter then becomes music in more than metaphor, and reality, a song with no beginning and no end, playing softly beneath the noise of everyday life. There's a kind of peace in that, isn't there? To know that your body, your breath, your thoughts are all part of a pattern so subtle it hums even in silence, even as you sleep. Let's pause here. We've travelled from electrons to quarks, from atomic clouds to cosmic dust, from the solidity of your pillow to the strange fuzziness of what lies beneath it. And through it all, atoms remain both deeply familiar and endlessly strange. They make up your world, but they are not your world. They make up your body, but they are not yourself. They are the notes. You are the melody. And somehow, without knowing it, you've been singing all along. Atoms are small, but their behaviour builds the world. And when you begin to understand how they behave, not just what they are, you start to glimpse something deeper, something that feels less like physics and more like poetry written in mathematics. Let's begin with one of their most important qualities, bonding. Atoms are social. They don't like being alone. When given the chance, they link together. Not out of loneliness, but out of energy, because nature is always chasing one thing, stability. And stability for atoms often means sharing. When two hydrogen atoms meet an oxygen atom, they form water. The oxygen needs 2 electrons. Each hydrogen has 1, so they share. Just enough. Just long enough. And suddenly, something new appears. A droplet. A wave. A falling rainstorm. This sharing of electrons is what we call a covalent bond. A kind of mutual agreement, like neighbours sharing a fence. Neither gives up their electron, but both benefit. Other atoms prefer different deals. Ionic bonds happen when one atom gives an electron and the other takes. Sodium gives, chlorine takes. Together they form salt. Something entirely different from the 2 elements alone. Sodium alone is explosive. Chlorine is poisonous. But together, they make the ocean taste like the sea. Then there are metallic bonds, where electrons aren't so much shared or traded, but allowed to drift. In metals like copper or gold, electrons float freely, forming a shimmering sea of charge. This is why metals conduct electricity. The electrons are already halfway to moving. All these bonds, covalent, ionic, metallic, are just different expressions of the same idea, that atoms, when connected, become something more than themselves. It's not unlike human relationships. We don't just coexist, we transform one another. From bonding comes chemistry, the mixing and rearranging of atoms into new molecules, new shapes, new functions. Chemical reactions are like conversations. Some are loud and explosive. Others are quiet, almost invisible. They can release energy, absorb it, change colour, change phase. They can turn wood to ash, iron to rust, seeds to saplings. Your very metabolism, every breath, every heartbeat, is the slow unfolding of chemical chains. Oxygen entering your lungs, binding to hemoglobin, delivering itself to cells. Glucose breaking down into ATP, the tiny packets of energy your body burns to blink, to think, to dream. All of it is atoms, all of it is motion, and yet the laws are elegant, predictable, orderly. Take the conservation of mass. It tells us that atoms don't vanish. In any reaction, what goes in must come out. Rearranged, yes, but never lost. That burning log becomes smoke, heat, light, and ash. But the atoms remain. They're simply on a new journey now. But not all atomic stories are so calm. Sometimes, atoms are pulled apart violently, or fused together under crushing heat and pressure. When this happens, we leave chemistry behind, and step into the domain of nuclear reactions. Let's begin with fission. In fission, an unstable nucleus splits into two smaller nuclei, releasing a tremendous amount of energy. It's the reaction that powers nuclear reactors, and, tragically, atomic bombs. The key is in the nucleus's balance. If it's too heavy, like uranium-235 or plutonium-239, it starts to wobble. Nudge it just right with a stray neutron, and it will break apart. The split releases energy. It also releases more neutrons. Those in turn hit other atoms, more splitting, more energy. This is the chain reaction, and when controlled, it can light cities. When uncontrolled, it can level them. But there's another path, one that powers not bombs, but stars. It's called fusion. Where fission splits atoms, fusion joins them. Light nuclei, like hydrogen, merge into heavier ones like helium. In the process, a tiny amount of mass is lost and turned into energy. This is how the sun shines. Every second, millions of tons of hydrogen fuse in its core, releasing energy that travels across space and lands softly on your face as sunlight. It's breathtaking to realize that warmth, that glow, began as atomic fusion. Something so small, so violent, now arriving as golden quiet. Fusion is cleaner than fission, more powerful, and in theory, limitless. But so far it's incredibly difficult to achieve on Earth. We need to recreate the conditions of a star. Temperatures of millions of degrees, incredible pressure, containment systems strong enough to hold plasma in place. And yet, we try, because the promise is too beautiful to abandon. Energy from the same source that lit the stars. It's worth pausing here. Because all of this, the bonds, the reactions, the transformations, they're not just physics problems. They're the grammar of creation. The same patterns that shape the first molecules on Earth are the ones dancing in your bloodstream now. And sometimes, the simplest shifts produce the deepest changes. Take carbon. One of the most common elements in the universe. Found in comets, in coal, in candlelight. Arrange its atoms one way and you get graphite, soft, black, used in pencils. Arrange them another way and you get diamond, clear, sharp, unbreakable. Same atoms, different bonds, different angles, that's all. Just a new geometry. And the world changes. Then there are allotropes like fullerenes and graphene. New shapes of carbon discovered only recently. Some sheets only one atom thick. Stronger than steel, lighter than air. A reminder, even the familiar still holds secrets. Atoms also misbehave. They have isotopes, variations in the number of neutrons. Some are stable, some decay slowly, releasing radiation over centuries. Others vanish in moments, flickering into other elements. We use these isotopes to date ancient fossils, to power space probes, to sterilize medical equipment, to treat cancer, to make smoke detectors work. They're strange gifts. Dangerous, yes, but also healing, illuminating. It depends, as always, on how we use them. And then there are the edge cases, the quantum oddities, the particles that seem to defy logic altogether. Take the Pauli exclusion principle, which says that no two electrons in the same atom can have exactly the same set of quantum numbers. It's a rule of uniqueness, a cosmic insistence that every electron must be just slightly different. Without it, atoms would collapse. Matter would fold inward. The universe, as we know it, wouldn't work. Or consider quantum tunneling, where particles seem to pass through barriers they shouldn't be able to cross. It's like watching a marble roll through a wall. Impossible in our world, but common in the quantum one. It's not magic, it's probability. Sometimes particles just appear on the other side. Tunneling is what makes the sun shine. It's what lets enzymes work inside your cells, and it's what fuels the dreams of quantum computers. Machines that could one day think not in ones and zeros, but in the strange maybes of superposition. So then, what happens when atoms begin to behave in ways that even atoms aren't supposed to? Let's drift, slowly now, into the edges, because at the farthest reaches of cold, near absolute zero, atoms begin to forget who they are. Normally atoms are distinct. They spin, they vibrate, they hold their space with pride. But cool them far enough, down to just a whisper above, 273.15 degrees Celsius, and something strange unfolds. The individuality fades, motion ceases, and thousands of atoms begin to act not like many things, but like one thing. This is called a Bose-Einstein condensate, a state of matter so rare, so quiet, so unlike anything in the everyday world that Einstein himself predicted it 100 years ago. And scientists only managed to create it in a lab in 1995. Imagine an orchestra where every instrument is playing in perfect unison, not just rhythmically, but literally sharing the same note, the same wave. That's a condensate. In this frozen hush, atoms behave like a single, unified wave function, a ghost of matter, a fog that flows without friction, no resistance, no chaos, just coherence, a song so low and soft it becomes stillness. And yet, this stillness reveals something profound, that matter isn't just what it appears to be, that when stripped of heat, stripped of energy, stripped of individuality, even atoms long to unify. It's not the only exotic state. Take superfluid helium. At low enough temperatures, helium stops acting like a liquid. It flows without viscosity. It can climb the sides of containers, spill over edges with no resistance. It doesn't slosh. It glides. Perfectly. Forever. You could spin it in a bowl, and it would keep spinning, even after days, weeks, without slowing down. It breaks the rules of common sense, but atoms at their extremes don't care much for common sense. Then there's entanglement. Einstein once called it spooky action at a distance, and to be fair, it is. Entanglement happens when two particles become linked in such a way that the state of one instantly affects the state of the other no matter how far apart they are. You could place one atom on the moon and the other in your living room, and still, the moment you measure one, the other knows. It's not communication, it's correlation, it's not cause and effect, it's being, shared, inseparable. And while we don't fully understand how it works, we've tested it, over and over, with photons, electrons, atoms, even small molecules. Entanglement is real, it's fragile, easily broken by noise, heat, or interaction. But when preserved, it's almost as if the universe is whispering to itself across space. There are atoms right now on Earth that are entangled. And if you're holding a phone or listening through a digital device, you're already benefiting from quantum mechanics. Because atomic behavior doesn't just stay in laboratories, it becomes technology. Lasers, quantum, MRI scanners, quantum, semiconductors, computers, LEDs, atomic clocks, quantum. The entire digital world is built, quite literally, on the strange dance of electrons inside carefully arranged atoms. We design chips by placing atoms with near-perfect precision. We tune their energies, shape their flow, control the gaps where electrons jump from one place to another, and out comes everything. Video, sound, thought, memory, all built on silicon itself, built from atoms. And now we dream bigger. Quantum computers are being developed, machines that harness superposition and entanglement to perform calculations far beyond what any classical computer can do. Imagine a computer not bound by binary ones and zeros, but capable of exploring all possibilities simultaneously. Not logic alone, but probability. Such devices could revolutionize medicine, cryptography, weather forecasting, material science, and they rely on the quiet mysteries of atoms. We've even begun experimenting with quantum teleportation, not of people, of course, but of information, transferring quantum states from one particle to another across distance. It sounds like science fiction, but it's real. There are labs today where information has been transmitted using entangled atoms, not moved exactly, but recreated, copied with such fidelity that it's indistinguishable from the original. In a sense, it's not the matter that moves, but the pattern, and perhaps that's what atoms are, at the deepest level. Not things, but patterns, vibrations in space, configurations of energy, temporary expressions of something deeper, like waves that rise, curl and vanish, only to reappear elsewhere. You might ask, is there a bottom, a smallest thing, a true building block of reality? And the honest answer is that we don't know. We've found quarks, leptons, bosons, fields, strings. We've built particle colliders to smash atoms into smaller and smaller parts, looking for that last indivisible dot. But the deeper we go, the more relational things become. Particles become probabilities. Positions blur. Identity wavers. There may be no thing at all, only interactions. And so the question changes. Not, what is matter made of, but what makes matter? Maybe it's not atoms, but rules. Not particles, but patterns. Not objects, but outcomes of relationship. Imagine reality as a tapestry, not woven from thread, but from tension, from connection, from the way energy curves and curls and folds. And within that tension, we emerge, built from atoms that do not care, and yet we do. We take the cold neutrality of electrons and turn it into art. We take the forces of fusion and warm our faces by firelight. We take the chance arrangement of molecules and write poetry with our hands. Atoms do not seek meaning, but we do, and that perhaps is what lifts matter into something more than matter. A molecule by itself is silent, but string enough of them together and you get memory, music, morning coffee, mathematics, mercy, meaning. Atoms have no story until you give them one. And so, we end this deep dive not at the edge of science, but at the centre of something quieter. You. You're made of carbon, oxygen, hydrogen, calcium, phosphorus, nitrogen. Simple atoms found in stars and sea foam, but you're also made of childhood, of laughter, of language, of 1,000 quiet atomic memories arranged into something fragile and awake. There's a line from Carl Sagan that says, "We are a way for the cosmos to know itself." Atoms, dreaming atoms. Perhaps that's what we are, and when you sleep, when your breath slows and your mind begins to loosen its grip, you return to something simpler, not gone, not erased, just softened, a gentle field, a ripple in a warm bed of particles folding slowly into rest. Once upon a time, we didn't know atoms existed, and yet we still asked what everything was made of. It's one of the oldest questions, maybe the first, not because it leads to an answer, but because it leads to wonder. The moment a human being looked at the world and thought, what is this really? Science began. The earliest ideas weren't based on evidence the way we think of it today. They were based on patterns, on intuition, on watching the way fire danced, or the way water flowed around the feet. In ancient Greece, over 2,000 years ago, a philosopher named Leucippus, and later his student Democritus, proposed something radical, that everything is made from tiny indivisible units, so small you can't see them, but always in motion. He called them atomos, which means uncuttable. To Democritus, atoms were eternal. They couldn't be created or destroyed, only rearranged. The world in his eyes was a swirling sea of atoms and void. Solidity, softness, flavour, even thought. All of it, he believed, came down to how atoms collided and combined. He was guessing, of course, but what a guess. it wasn't widely accepted. The more influential philosopher Aristotle disagreed entirely. He believed matter was continuous, made from 4 elements: earth, air, fire, and water. Simple, elegant, spiritual. His view carried the weight of logic and tradition, and for nearly 2,000 years, it was the dominant view in Europe and beyond. Atoms, it seemed, were forgotten, until the world began to change, fast forward to the 17th century during the scientific revolution. Europe was beginning to awaken from centuries of dogma and into a new era of careful observation and curiosity. Robert Boyle, often called the father of modern chemistry, began to question the old 4-element system. He believed in elements, yes, but not fire or air or water. He defined elements as substances that could not be broken down further. He didn't have a periodic table, but he was searching for one. Then came Isaac Newton, who believed in something like atoms too, tiny, hard particles moving according to physical laws. He couldn't see them, but he saw their effects in gases, in motion, in the behaviour of light. Still, no one had seen an atom. They were theoretical, invisible. It wasn't until the early 19th century that the idea of atoms returned with force, this time backed by science. A quiet English school teacher named John Dalton noticed that chemical reactions always happened in fixed ratios. Water was always 2 parts hydrogen, 1 part oxygen, no matter how much you started with. Dalton proposed that this could only be explained if matter were made of indivisible units, atoms, each with a specific weight. He gave us the first modern atomic theory. Atoms were back. By the mid-1800s, Dmitry Mendeleev, a Russian chemist with a flair for patterns, created the periodic table, organising elements not just by their weight, but by their properties. The elegance was astonishing. He even left gaps for elements that hadn't been discovered yet, and predicted their properties with eerie precision. And again, the atoms revealed themselves, not directly, but through the order they left behind. Still, no one had seen one. Not yet. But cracks were forming in the model. Atoms weren't quite as simple as we thought. Enter the late 19th century, and an unexpected hero: electricity. Scientists began experimenting with something called cathode rays, streams of particles moving through a vacuum. A young physicist named J.J. Thomson studied these rays and realised something shocking. They were made of tiny, negatively charged particles, smaller than an atom. He had discovered the electron. Suddenly atoms weren't indivisible after all. They had structure, internal parts, mystery. Thomson proposed a new model, the plum pudding model. He imagined atoms as a soft, positively charged sphere, studded with tiny electrons like raisins in a pudding. Strange? Yes. But it was a step. Then came the gold foil. In 1909, Ernest Rutherford, a student of Thomson's, conducted a delicate experiment with alpha particles, tiny bits of radiation, firing them at a sheet of thin gold foil. Most of the particles passed through, but a few bounced back, hard. Something inside the atom was solid, dense, powerful. This led Rutherford to propose a new atomic model. Atoms have a small, heavy nucleus at the centre, where most of the mass resides, and electrons orbit around it like planets. It was elegant. It made sense. But it wasn't quite right, because planets have predictable orbits, and electrons do not. Enter Niels Bohr in 1913. He refined Rutherford's model, suggesting that electrons exist in specific energy levels, quantized shells around the nucleus. They could jump from one level to another, but not exist in between. It was closer, but reality was slipperier still. At the same time, another revolution was unfolding: quantum mechanics. Scientists like Werner Heisenberg, Erwin Schrödinger, and Max Planck realised that particles don't behave like tiny billiard balls. They behave like waves, unpredictable, probabilistic. You couldn't know exactly where an electron was, only the likelihood of where it might be. This wasn't just a tweak, it was a complete reimagining. The atom wasn't a miniature solar system, it was a cloud of probability. And inside the nucleus, more mystery. In 1932, James Chadwick discovered the neutron, a neutral particle that helped hold the nucleus together. Now the atom had three parts: protons, neutrons, and electrons, a new trinity, a stable one. And finally, in the 20th century, we saw it, for the first time. Using a technique called scanning tunneling microscopy, scientists captured images of atoms, blurred ghostly dots, not photographs, but impressions, traces of presence, whispers of reality. The atom, once imagined, once denied, once debated, was now visible. And yet even visibility didn't mean full understanding. The deeper we looked, the more complex things became. Quantum electrodynamics, quantum field theory, the Standard Model, quarks, gluons, bosons. The simplicity of the building block gave way to something more dynamic. We no longer thought of atoms as tiny spheres. We saw them as excitations in a field, as temporary patterns, as waves that appear when we observe and dissolve when we don't. Even the boundaries between matter and energy blurred. Einstein's famous equation, E = mc2, told us that mass is energy, that under the right conditions you can turn one into the other, that the atom is not just stuff, it's potential. And today, we smash atoms in enormous machines called particle accelerators, like the Large Hadron Collider. We break them apart not to destroy them, but to understand their pieces, to learn what's left when everything else is gone. And yet, the story continues. We've mapped the atom, split it, measured its parts with mind-bending precision. But we still don't know everything. We don't know what dark matter is. We don't know why the universe has more matter than antimatter. We don't know if quarks are truly fundamental, or if something smaller still waits behind the curtain. Each answer becomes another question, each discovery another door, and maybe that's the beauty of it. The atom began as a guess, a metaphor, a dream, and even now, after centuries of progress, it remains strange, slippery, sublime. We understand it better than ever, and yet it still humbles us. Because even as we uncover the structure of reality, we're reminded reality is more than structure. It's the wonder that draws us toward it. It's the long, slow journey from "what is this?" to "I don't know yet." It's the fact that we keep asking, and that maybe is the real history of the atom, not the timeline of its discovery, but the story of our longing to know. Close your eyes for a moment, not to shut the world out, but to let something in. Now imagine, you're lying on your back beneath a canopy of stars. Above you, infinite, eternal. Below you, soil, silent and soft. You're held between sky and earth. But what exactly is you? You've heard that you're made of atoms, that these invisible, restless particles are your true substance, your blood, your thoughts, your breath, your bones. But if you're made of atoms, and the chair you're sitting in is made of atoms, and the stars above are made of atoms too, then what exactly is the difference? Why do you feel like something? Why does the universe, through you, become aware of itself? This is not a question with an easy answer. Atoms, for all their precision and predictability, give rise to the most unpredictable mystery of all, consciousness. And that mystery lives in you. Let's step away, just for a while, from the diagrams and definitions. Let's leave the nucleus behind, float past the electron cloud, and settle into the space between the facts, into the warm, blurry threshold where science starts to echo philosophy and physics begins to rhyme with feeling. Because even after centuries of study, we still do not know what it means to be made of atoms. We know how they behave. We know how they bind. We know their masses, their charges, their dance steps. But why do they give rise to this? To hunger, to music, to longing? You've never seen an atom laugh, but you've laughed. You've cried. You've stood alone in a kitchen at 2 a.m. and felt a feeling that had no name but still mattered. Where was that feeling in the Standard Model? Where is tenderness in a particle collider? You could map every molecule in a teardrop and still not know why it fell. So perhaps atoms are not the whole truth. Perhaps they are the surface of truth. And truth, like light, has a depth to it. Let's consider something strange. You've been told that atoms are mostly empty space, that the space between the nucleus and the electron is vast, proportionally vaster than the distance between planets and their stars. If you could compress all the atoms in your body to remove that space, you would fit into something no larger than a grain of rice. So why don't you fall through the floor? Why don't you dissolve into everything you touch? The answer is subtle. It's not solidity that holds you up, it's repulsion. Electron fields resisting overlap. An illusion of touch made real by the laws of quantum mechanics. Your hands never truly touch anything, they hover, they repel. So much of what we call contact is not contact at all, just proximity and resistance, just space pretending to be substance. And yet, it works. We fall in love with people we've never touched. We feel homesick for places we haven't seen. We ache for futures that haven't happened. So what is real? Is it the atom or the ache? Some scientists have begun to wonder whether reality is even made of matter at all. What if the fundamental stuff of the universe isn't particles, but information? Think of it this way. An atom is not just a thing. It's a configuration, a set of relations, an event that happens in a context. In this view, the universe is more like a computer than a machine. Matter becomes data. Interaction becomes code. You become a program, a song, a temporary ripple in a sea of logic, not meaningless, just formless beneath the form. You may have heard of something called simulation theory. It suggests, not as fantasy but as probability, that if conscious beings ever learn to simulate an entire universe, and if they do it often, then statistically it's likely that we're already inside one. A dream inside a dream. A rendered world. But even if that's true, so what? If a sunset still brings you peace, is it less real? If a kiss still makes you tremble, is it just pixels? Does love disappear if it's programmed? Or is it realer because it's felt? These questions aren't meant to unsettle, only to soften the borders of certainty, to remind you that atoms, for all their importance, are only part of the picture. They are the language, not the meaning. They are the ink, not the poem. And what a poem it is. Because here you are, listening, breathing, remembering some long-forgotten moment that had no atoms in it at all, only warmth. Even memory defies physics. It's made of molecules, yes, stored in neurons, written in electrochemical pulses, but the feeling of a memory, the ache in your chest when you remember someone's voice, that is not stored in a molecule. That is you, existing in two places at once, now and then, past and present, stitched together by something atoms cannot name. We could go further still. Some physicists believe that time itself may not be real, that it emerges from entropy, that it's a statistical blur, that the past and future are illusions, and only this breath, this second, truly exists. If time is not real, and atoms are not solid, and matter is just structured energy, then what are you? Not a body, not even a mind, but a moment, a rhythm, a pattern of patterns shimmering for a little while before dissolving back into the music. And maybe that's beautiful, because a diamond is not made of eternal stuff, it's made of carbon. What makes it precious is not its atoms, but the way they're arranged. The same is true for you. You are not your ingredients, you're your arrangement. And the way you see the world, that too is an arrangement. Some days you feel like light, other days like dust. But both are made of atoms, and both are true. So what do we do with all of this? Do we collapse into nihilism? Do we declare life meaningless just because it's made of borrowed parts? No, we celebrate it. Because impermanence is what gives life meaning. Because knowing that we are made of stardust makes stargazing sweeter. Because knowing that atoms do not care, and yet somehow we do, makes every act of kindness a small defiance against the void. It means we matter, not because of what we're made of, but because of what we choose to make. A meal, a promise, a song, a life. Atoms don't know about beauty, but you do. Atoms don't feel time passing, but you do. Atoms don't wonder what happens after death, but you do. And that wonder is sacred, because it's rare, because it means the universe woke up, even if just for a moment, and saw itself, through you. And maybe that's what you are. Not just a body, not just a story, not just a ripple in a sea of particles, but a question the universe is asking itself. What am I? What could I be? And maybe there is no final answer. Maybe that's the point. To keep asking, to keep wondering, to keep becoming. So tonight, let the atoms do their work. Let them pulse. Let them hum. Let them forget themselves for a while and just be still. Let the questions drift like smoke, not needing answers, only space, only softness, only the quiet truth that you are here. You're made of everything, and you are making meaning out of it. Atoms are not rare. They're not special, exotic, or hidden in some distant corner of the universe. They're here, everywhere, in everything, all the time. They're in the steam rising off your tea, in the floor beneath your feet, in the molecules dancing on your skin right now, brushing invisibly against the air. They're your breath, your thoughts, your dreams. The strange, quiet truth is this. You've never known a world without atoms, but you've also never seen one. Not directly. Atoms don't wave. They don't announce themselves. They don't glow when they pass by. They do their work in silence, invisible, relentless. They don't care what form they take. They just arrange. Sometimes as bone, sometimes as rain, sometimes as cinnamon on warm toast. Strange, isn't it? To know that your entire experience of life, your favourite sweater, your childhood memories, your laughter with a friend, is built from things that are mostly empty space. And yet here you are, held together by something. Every object around you is a temporary agreement of atoms. Your phone, your pillow, the doorknob you twist every day without thinking, the reflection in your mirror. They're not permanent, not stable in the long term. They're borrowed, pieces of the universe just pausing for a moment to become your toothbrush, your shoes, your favourite pen. Even your body is on loan. Your cells are constantly dying and being replaced. Your atoms are in flux. Your liver renews itself every few months. Your skin is always shedding. You're not the same person you were a year ago, chemically speaking. And yet, you feel continuous. Isn't that wild? That continuity comes not from your atoms, but from your awareness, your story, your sense of self, built not from particles, but from pattern. And still, that pattern is written in atoms. Let's bring this closer. Look at your hands. Right now, if you want, they're made of carbon, oxygen, hydrogen, nitrogen, calcium, and trace amounts of other elements, same as the soil, same as the stars, same as the bones of whales and the bark of trees. And yet, those atoms are you. They respond to your decisions. They turn pages, hold spoons, pick flowers, build lives. The atoms don't know what they're doing, but you do. You give them purpose. And in doing so, you give yourself a kind of invisible companionship. You're never alone, not really. You're always surrounded by trillions of little travellers, atoms that used to be somewhere else and soon will be somewhere new. There's something beautiful about that. Every glass of water you drink contains molecules older than the Earth itself. Every breath you take is shared with everyone who has ever lived. Napoleon, Cleopatra, dinosaurs, dandelions. You're not just in the world, you're of it, completely. Even the idea of you is permeable. Your body interacts with the world constantly, exchanging atoms with every bite, every breath, every touch. The boundary between self and not self is softer than we think. When you eat a meal, your body doesn't just digest it. It absorbs the atoms and weaves them into your muscles, your blood, your brain. The food becomes you. And eventually you become food for something else. Not in a grim way, in a circular way, in a sacred way. In many cultures, this idea of interconnectedness is not a scientific novelty, but a spiritual truth. Hindus speak of Brahman, the idea that all things are made of the same divine essence. Buddhists see the self as an illusion, a temporary arrangement of causes and conditions. Indigenous cultures around the world describe the earth not as a possession, but as a living being, one we are part of, not separate from. Modern science, in its own language, is echoing these ancient insights. Atoms aren't just the ingredients of your body. They're the threads of a web that stretches through space and time. When you burn wood, carbon is released into the air. That carbon might settle into soil, be absorbed by a root, rise through a tree, become a leaf, be eaten by a caterpillar, which is eaten by a bird, which molts a feather, which drifts onto your windowsill. The carbon from that feather might someday find its way back into you. A breath is not just a breath, it's a reunion. And we experience these reunions constantly, whether we recognize them or not. A hug, a meal shared at the same table, two people falling asleep beside each other exhaling into the same pocket of air, everyday magic powered by atoms. You might not think of science when you sip your coffee, but that warmth, that flavour, it's atoms vibrating in specific patterns, triggering receptors on your tongue. That pleasure is chemistry. Chemistry is atoms. And atoms, well, you know by now, are ancient, wild, loyal little things. They give without question. They serve without ego. You don't need to believe in miracles to feel grateful for a warm shower, a bowl of soup, the feeling of clean sheets, because even the mundane is made of stars. Let's stay with that idea for a moment. We say, we are made of stardust, and we are. But that phrase gets thrown around so often it can lose its weight. So let's return to the literal truth. The early universe, moments after the Big Bang, was a hot, dense cloud of hydrogen and helium. That's it. No carbon, no oxygen, no iron. The elements that make you had to be forged in stars, inside nuclear furnaces, under unimaginable pressure and heat. Stars live and die and explode. And in those final brilliant moments, they scatter the ingredients of life across the galaxy. And those atoms travelled. They cooled. They collected. They formed planets, oceans, organisms, and eventually you. A being capable of remembering, wondering, loving, laughing. You are what stars dreamed into being. Your life is not separate from cosmic history. It is cosmic history, still unfolding, still becoming, and so the ordinary becomes sacred. A walk becomes a procession of atoms. A sigh becomes the whisper of time. A shared glance becomes the alignment of fields. Even boredom, even the feeling of nothing happening, is a symphony of stability, of atoms holding their shape long enough for you to yawn and think, I'm tired. You might wonder, if everything is made of atoms, does that make everything the same? No, because atoms are only the beginning. The real wonder is in the arrangement. Just as the same 26 letters can write every book in your library, the same atoms can become anything. It's how they come together that makes meaning. So yes, you're made of the same stuff as everyone else. But the way your atoms are arranged, your voice, your heartbeat, your memories, your peculiar way of laughing at terrible jokes, is utterly unrepeatable. There will never be another pattern quite like you. And that's worth remembering. Because on difficult days, when you feel small or insignificant, it helps to remember this. You are not insignificant. you're improbable, statistically miraculous, a fleeting constellation of atoms that have travelled for billions of years through stars and soil and sea just to become this moment, this breath, this being, you. What if reality isn't what it seems? What if the atoms that build our bodies, our oceans, our songs and sorrow, are only one version of reality, a version tuned to our senses but not the whole truth? Let's start small. Right now, you feel still. Your body, warm and quiet, is lying or sitting or resting somewhere safe. But on the atomic level, stillness doesn't exist. Your atoms are vibrating constantly, endlessly. Even in sleep, even in death, atoms never stop moving. If your body could be shrunk 1,000,000 times, you'd see a world in motion. You'd see electrons dancing, fields pulsing, particles flickering in and out of probability. Not quite here, not quite there. Because location, in quantum mechanics, is not a point. It's a probability. Atoms don't exist in one place until they're observed. They're smeared across possibility, like moonlight on water. And this raises the first what if. What if reality is not fixed until you look? This is more than a poetic idea. It's built into quantum theory. In the famous double-slit experiment, particles behave like waves until observed. Then they behave like particles. Measurement seems to collapse the wave function, solidifying one outcome from many. Some interpret this to mean that observation shapes reality, that consciousness selects the path. Others say no, that it's not your mind that matters, but any interaction, a particle detector, a molecule, a piece of film, but the question lingers, does the world exist as we know it, without someone, or something, to notice it? And if not, what does that make you? A participant? A co-creator? A mirror the universe holds up to itself? Or maybe just a ripple, like everything else? Let's go further. What if you could split yourself? Not metaphorically, thus literally. Quantum physics allows for the possibility that every decision, every outcome creates a branching timeline. One where the coin lands heads, another where it lands tails. One where you say yes, one where you say no. This is the many worlds interpretation. In this view, every possibility plays out, somewhere. There's a version of you who never watched this, a version who watched it twice, a version who became a musician, or a monk, or never moved out of your childhood town. Each version equally real, equally present, equally you. But you can never meet them, not because they're far away, but because they're orthogonal, elsewhere in the fabric of possibility. And here's a twist. From their perspective, you are the unreal one. You are the what if, a ghost in someone else's timeline. So what does that mean for choice? If everything that could happen does happen, is anything special? Are you free? Or are you just playing out your version of a branching script? That's the paradox. You feel free. You make choices. And yet, you're made of atoms which follow laws. Does the illusion of agency arise from complexity? Or is there something deeper? Some quantum indeterminacy that gives you wiggle room? We don't know. And maybe that's the miracle, that you get to act as if you're free, even in a world of cause and effect, as if you are more than your molecules, even if technically you are your molecules. But even that may not be permanent. Let's imagine teleportation, not science fiction, real quantum teleportation. It doesn't move your body, it moves your state. In labs today, scientists have teleported quantum information, the arrangement of one atom, across space using entanglement, not the atom itself, just the pattern. One atom here, one atom there, and the state jumps instantly. What if one day that worked at scale? What if we could map your body atom by atom, then recreate it on the moon? Would the result be you, or a perfect copy? And if the original was destroyed, would anything be lost? Is continuity of matter essential to identity, or is pattern enough? If I copy a poem word for word and burn the original, is the poem gone? No. But a poet is not a poem. Are you? Let's say we build a machine, a molecular assembler, that can reconstruct you atom by atom from a blueprint. Could it reassemble your memories, your voice, your pain? If it did, would you still be you? Or would the you that's asking this question be gone forever, replaced by someone who thinks they're you? Would it matter? Here's another twist. If we ever do create artificial consciousness, if we can simulate a brain so accurately that it behaves just like a person, then the distinction between real and artificial may dissolve. And if we can simulate one brain, why not a whole world? This is the simulation hypothesis. If it's possible to simulate a universe, and civilizations are likely to do so, then statistically we are probably inside one. It sounds absurd, but the math doesn't laugh. So then, what if your atoms aren't atoms at all? What if they're bits, pixels, instructions in a cosmic rendering engine? Would it change anything? Would your tears be less salty? Would your memories be less sweet? Probably not. Because the experience is still real. And that's the thing no model, no simulation, no philosophy can erase. The experience. Even if your atoms are illusions, the kiss still tingled, the sun still warmed your face, the song still broke your heart. And if atoms made that possible, whether real or simulated, then they've done something miraculous. Now, let's drift further. There are theories that say reality is not continuous, but quantized, like pixels, but for space and time. Below a certain scale, space stops being smooth, time stops flowing. Instead of a river, it's a flicker, a sequence of moments, a cosmic film reel, and in between each frame, nothing. So what happens between the moments? Do we still exist? Or are we only awake when the universe blinks? And if we only blink on and off, again and again, then what is consciousness? A kind of animation? A self-reinforcing hallucination that gives meaning to each moment, even as they're stitched from nothing. There's also a theory that particles, electrons, photons, aren't separate at all. That they're all the same particle, looping through time, a single entity, weaving in and out of history, seen from different angles. That every particle of light you've ever seen is the same photon circling through space, like a needle threading the fabric of now. And if that's true, then maybe your body isn't made of many atoms. Maybe it's made of one infinite loop of being, appearing as many, because of perspective, because of the angle we view it from, or the illusion of division. But now let's make it simple again. Because even if none of this is true, even if there are no parallel worlds, no simulations, no teleportation, you still wake up, you still breathe, you still love, and that's its own miracle. Your atoms may follow rules, but your attention doesn't have to. You can give meaning to anything. A rock, a ring, a room where someone once laughed. That's not science fiction. That's presence, that's agency, that's what if made real. So tonight, as you close your eyes, as your atoms settle into the stillness of sleep, let your thoughts wander, not in fear, but in play. What if you are dreaming this life? What if, tomorrow, you wake up as a beam of light? What if you're a star, pretending to be a person, just to feel what it's like? What if every atom in your body remembers something you don't? Not a story, just a rhythm, a pattern, a pulse, a note in a song the universe has been singing since the beginning. You don't have to understand the whole melody. You only have to listen, and you are. So we've wandered quite far tonight, from the smallest particles to the farthest stars, from quarks to questions, from fact to feeling. You've heard that you're made of atoms, but maybe now you've felt it too. Maybe you've come to see it not just as a scientific truth, but a poetic one. Something lived, something breathed. Because being made of atoms is not just about carbon, nitrogen, oxygen, and iron. It's about being part of a pattern. One that began before you were born. One that will continue long after you're gone. And still. One that, for a little while, is you. We began with a simple question. What is reality made of? And the honest answer is, it depends on how you look. From one angle, reality is made of particles. From another, it's made of probability. From another, it's made of perception. From another still, perhaps it's made of stories. Because reality is not a fixed shape. It's a prism. It bends light differently depending on where you stand. What is a chair to a physicist? A lattice of molecules, interlocking carbon chains. But to a child? It's a castle. To someone grieving, an empty place. To someone tired, a soft place to rest. Same atoms, different realities. So maybe atoms are just the raw material, the alphabet, the stage. And we are the meaning. We give names, we build feelings. We turn structure into significance. We make atoms into a home. Let's take a breath. Notice where you are right now. Not just physically, but emotionally. Maybe you're feeling calm, or curious, or a little sleepy. Maybe you're remembering something, someone. Maybe you're feeling small, but in a good way. That's okay. Atoms don't take things personally. They don't know what a you is, but you do. You know what it's like to miss someone, to hold a hand, to say goodbye. Atoms make all of that possible, but they don't understand it. That's your job. That's what makes you different from a rock, or a star, or even the universe itself. You feel, you reflect, you tell stories to yourself about who you are, where you've been, what you hope for. Those stories might not be made of atoms, but they're written in atoms. Every thought you've ever had is a chemical flicker. Every dream, a temporary reshuffling of molecules in the brain. And yet, you're not limited to those reactions. You take them, and you make meaning. You make beauty. You turn reality into poetry, even when it hurts. Maybe especially when it hurts. So, what are you? Are you a collection of particles? Yes, but also, no. You're more than the sum. You are memory, and intention, and wonder, and that last one, that one really matters. Because when we forget to wonder, the world becomes grey, routine, mechanical. But when we remember, suddenly, even the dust on a bookshelf feels ancient. Even the condensation on a glass feels like magic, because it is. Everything is. Let's go back just for a moment to that first atom, not the first one in your body, the first one in the universe, hydrogen, born in the silence after the Big Bang, a proton, a little positive charge, floating, lonely in the newness of everything. It had no name, no purpose, and yet it endured. It became part of a star, which became part of a supernova, which became part of a planet, which became part of a flower, which became part of a person, which became part of you. And now here you are, breathing, feeling, listening. That same hydrogen, unchanged. But part of something new, a story, a self, a consciousness. That atom doesn't know what it's doing, but it brought you here. And now you do know. You know what it means to be alive, to be afraid, to be in love, to lose someone, to hope. And if an atom, simple, silent, ancient, can lead to that, then there's more wonder in a teaspoon of water than in all the fiction we could ever write. Let's stay here for a while. Let's name some things that are real. The way your chest rises and falls when you're calm. The warmth of your skin. The quiet ache in your throat when you remember a moment too beautiful to return to. The joy of a breeze. The peace of a blanket. The miracle of noticing. Those things are not scientific measurements, but they are real. Just as real as electrons, just as valid. You can believe in both. You can hold the universe in your hands and still weep at a song. You can admire the math of atoms and still believe in love, not because it's measurable, but because you feel it. And feeling too is a form of truth. Tonight you've travelled through time, from ancient Greece to quantum mechanics, from galaxies to skin cells, from simulation theory to poetry. And now you are here. Exactly where you began, but changed. Slightly. Softly. Not with answers, perhaps, but with a deeper kind of knowing. One that doesn't need to be proven. One that simply is. That you are made of stardust, yes, but also of stories. That your atoms are borrowed. But your awareness is uniquely yours. That the universe is not just around you, it's in you. That you're not a stranger to the world. You are the world, temporarily arranged to ask, what am I? And even if no final answer comes, the asking is enough. The wondering is enough. The being is enough. So let your shoulders drop. Let your mind soften. Let your breath deepen. You don't need to solve anything right now. You are already whole, already here, already part of it all. Sleep will come soon. Let it. Let your atoms rest. Let your thoughts blur. Let the rhythm of the night take over. Because even in sleep, your atoms are loyal. They hold your shape. They cradle your thoughts. They wait. And tomorrow when you wake, they'll be there, quiet, invisible, faithful. So, where are you now? What time is it? Where you are? Maybe it doesn't matter anymore. Maybe time, like atoms, has faded into softness. All that matters is this moment, this quiet, this breath. If you've made it this far, then thank you. Thank you for being here. Thank you for letting yourself slow down. Thank you for wondering with me. Your atoms, ancient, restless, stardust things, have held their shape all day just to carry you to this moment of stillness. And now they're ready to rest too. Let them. Let the questions drift. Let the world dissolve. Let sleep begin to rise, like a tide pulling you gently toward its shore. And if this gave you peace, if something here soothed even one small ache, then I'm glad. Because science isn't just about knowledge. It's about comfort, perspective, belonging, and you belong. Here, now, always. So sleep well, fellow traveller, wherever you are, whenever you are. You're made of atoms, but you are more than that. You're the quiet between particles. You're the noticing. You're the moment the universe looked at itself and smiled. Good night.